Good morning. We start with the next part, that is part 5. Here we will discuss about multiple and submultiple angles formula and also the sums. So this is the point of discussion today. First we are going to discuss the formula and after that the sums related to this. Now what is this multiple and submultiple angle formula related to trigonometry? So in very simple language, if you take the multiples of the angles, like say something like 2a or 3a, 4a, anything, 5a, anything like say 100a even, and many angles, whichever you know, however big may be. So what we are doing, we are actually increasing angle A by certain multiples. So this create the multiple angles, and similarly the submultiple angles are related to the fractions. So from A, if you write like A by 2 or A by 3 or A by 4, anything like this, say A by 16, anything, etc. So these are the related submultiple angles, you can say. So now we have to learn the formula related to this multiple and submultiple angles. So I start with this multiple angles. Now if we know the multiple angle formula, automatically the submultiple angle is covered, because it's the same kind of pattern, same kind of structure we get for multiple and submultiple angles. So if we cover up multiple angle formula, so submultiple angles will also be covered. So let us see. So number 1, I write over here sine 2a. Now sine 2a, please look at it. This is nothing new. This is nothing new because it comes from the formula of sine a plus b. So you have already seen the formula of sine a plus b in compound angles. So if sine a plus b, both a and b are replaced with a, that means you can write a plus a. So it becomes what? Sine a cos a plus cos a sine a. So it becomes 2 sine a cos a. So that is it. So open the chart of the compound angle formula. Okay. And after that you keep on replacing b with a. So you will get this. So it's 2 sine a cos a. So this is how sine 2a is derived. But please remember, derivation is fine, but you have to learn it and remember it for doing the sum or for working purpose. So next is cos 2a. Similarly you can put in cos a plus b. So okay, so you will get something like cos square a. You just put and taste whether you are getting the same thing. That means what I am doing, I am putting a equals to b or b equals to a, both, where in sine a plus b. So I am getting what? Sine 2a. So use this formula and derive it. Okay, that is it, simple. Now cos 2a will be cos square a minus sine square a. Okay. Now after this cos square a minus sine square a, we get another formula for cos 2a. If I replace this sine square a by 1 minus cos square a, I get 2 cos square a minus 1. Okay. Now if I replace this by 1 minus sine square a, I get 1 minus 2 sine square a. So there are 3 formula lines for cos 2a. Okay. Number 3, if I write, I'll use this line, the second line. I'll shift it, so I write 2 cos square a. What is 2 cos square a? 2 cos square a will be something like 1 plus cos 2a. So learn this also. Now I will use the sine formula, 1 minus 2 sine square a. Here 2 sine square a will be 1 minus cos 2a. Okay. So now if I divide 4 by 3, if I perform a division, that is 4 by 3. Okay. So I get a tan square a. Just see what I get, 2 sine square a by 2 cos square a, 4 by 3. 4 by 3 means line number 4, formula line 4 divided by formula line 3. So I get tan square A, which is equal to 1 minus cos 2A by 1 plus cos 2A. Okay. So this is tan square A. Now if you want to write, then what will be tan A? So tan A will be nothing but this whole thing will come under root. So 1 minus cos 2A whole divided by 1 plus cos 2A. Okay, so these are the few formula which I wrote. Now I will write some more also over here. So now we are going to visualize. So we have done with cos 2A and sin 2A. So now I want to write formula of tan 2A. So tan 2A also, if I write, so you will put B equals to A in place of tan A plus B. Okay. So that means tan A plus tan B divided by 1 minus tan A tan B. So in that situation it will be tan A plus tan A. That means 2 tan A divided by 1 minus tan square A. So this is it. Number 8. You can write cot 2A also. Cot 2A you know, cot B plus cot A below. So it will be 2 cot A and this is cot square A minus 1. So these are the formula. Nothing new, but you have to remember, you have to be a little conversant with this. Number 9. Number 9, we refer to some 3 angles. So 2A angles covered. 3A angles I will write something like sin 3A. Now sin 3A is a formula which we have never done before. That means we never did sin A plus B plus C. So if you expand that sin of A plus B plus C and put C equals to B equals to A, so you will get this thing, that is 3 sin A minus 4 sin cube A. So this is the formula which you can get after a little bit of simplification. So you can derive it also. If you derive it also, you will get a better understanding and concept also. So cos 3A next. Cos 3A is kind of alike. You will see this is 4 cos cube A minus 3 cos A. So this is the formula of cos 3A. Look at it. Now finally I will write a formula for tan 3A. So tan 3A uses the biggest formula, which is tan of A plus B plus C. So open the chart of compound angles, you will find tan of A plus B, where B and C are replaced with A. So you get what? Tan A plus tan B plus tan C. So that thing you are going to write tan A plus tan A plus tan A. So here you will get 3 tan A minus tan A tan B tan C. All of this will be tan A, so tan cube A whole divided by 1 minus 3 tan square A. So this is actually the formula list of multiple angles. Now what we are going to do, we will write a few of the submultiple angles. So I told you that once you know the multiple angles, the submultiple angles will be very easy because they use the same structure out of it. So we will try to learn the submultiple angles. Let's start that also. So what I'll do, I'll show you that how. Let us do first, let us do some other examples using this. Say I want to write, say, sine of 10A. Okay, so I want to write this formula, sine of 10A. Now sine of 10A, just look at it. We don't know the formula of sine of 10A. So what we will do, we will write in using the structure of this. So let us look at this sine 2A equals to sine A cos A. So what we can see that the left hand side A, right hand side A and the left hand side is 2A. So the angle ratio is 2:1, or you can say the left hand side angle is just the double of right hand side. So if you maintain this, so you can write sine of 2 into 5A, where this becomes the theta, and you can write 2 sine 5A cos 5a. So that means sin 10a becomes 2 sin 5a cos 5a. So here you see the angle ratio is again 2:1, 10a and 5a. So it becomes 2:1. So in this way we can write, say something like, I want to write sine of say 6a. So sine of 6a is a very interesting thing where you can actually use sine 2a also and also sine 3a. Okay. So if I use sine 3a, this formula, so I might write something like sine of 3 thrice of 2a. So look at the angle ratio again, 3:1. That means this is 3a and this is a. So thrice. So 3 into 2a means it will be something like 3 sine 2a minus 4 sine cube 2a. So like that the formula are written. Okay. Now let us do one tan thing, something like say tan of anything like say 6a. So if you write tan of 6a, so that means if you use this tan 2a structure, so it will be tan 2 into 3a. So this is becoming my theta. So what I can write, 2 tan 3a whole divided by 1 minus tan square 3. So like that you can write many multiple angles, any angles possible. So you can practice writing this possible using the structure of this. Okay. Now let us, I will show you, let us write some submultiple angles also. Submultiple angles, I will wrap this part. Say I do in the small part, I will show you something like say tan a by 2. So if I write tan a by 2, then what will happen? Okay. So use this structure. Say I want to write in this structure tan a by 2. So it will be same kind of thing, 2 tan something by 1 minus tan square something. Okay. Now what will be this something? That means what will be this angle in the bracket? What will be this angle? So look at it, you know this is 2:1. So that means this angle is actually twice of this angle. So it will be a by 4. That means if you multiply 2 with this, you will get this. So it will be a by 4. So what this angles you get in fraction. So they are becoming now submultiple angles. Now if I want to write sine a, the sine a will be what? 2 sine a by 2. Then cos a by 2. That also I can write using the first formula over here I get. Okay. Some more formula if I want to write, say something like say anything like cos a. What is cos a? If you use the structure of this, say the second line, this line, so you will get 2 cos square a by 2 minus 1. Why so? Because you note that this angle is double this angle, so 2 cos square a by 2. Now if someone wants to write this, what will be tan a by 2 using this number 6? Okay, what will be tan a by 2? So you see the structure, it's under root. So this angle is, the angle ratio will be 1:2. So it will be something like 1 minus cos a by 1 plus cos a. Okay, so this is actually kind of, so you need the same structure we are reusing. So you need to remember this first 11 and you can write any formula you want. So these are the formula with submultiple and multiple angles. Now we can proceed with a few sums related to this. Let us do that. So we will do a few sums on multiple submultiple angles. So I have written question number 1. So we have to find tan 22 and half degree. Okay. So tan 22 and half degree means you can write, it's something like 45 is pi by 4, that means this is pi by 8. Okay. Now As we know that tan 45 is 1. Okay. Now we can use the tan 2a equals to 2 tan a by 1 minus tan square a formula, or this is a kind of submultiple we are using. So if we consider this as theta and this is as 2 theta, okay, so it becomes 2 tan pi by 8 by 1 minus tan square pi by 8, which is equal to 1. So we can assume this tan pi by 8 as something like x. Okay. So if that is the thing, so we can write 2x by 1 minus x square, which is equal to 1, and we get a quadratic, that is x square plus 2x minus 1 equals to 0. So we will get something like so x equals to, I got minus 1 plus minus root 2. That means x is what? X is tan pi by 8, which is tan 22.5 degree. So here you see we have to discard the minus, because both of this minus root 2 minus 1 will turn this value to be negative, and that is not possible. Why not possible? Because we know that tan pi by 8 will be positive, since this is in the first quadrant. So that means here x will be equal to root 2 minus 1. Okay, that means tan pi by 8, which is tan 22.5 degree, the value will be root 2 minus 1. Okay, so this value, it's discarded. Write it. It's discarded. Why? Since tan pi by 8 is greater than 0, it is in first quadrant. So I write everything clearly for you. So this will be the answer. So this is the answer. Okay. Let us proceed to the next sum.